In this presentation today, we'll be exploring a new suite of creative design tools in formZ and how they can be used to enhance your modeling and design capabilities using a variety of parametric map-based form generation, cell diagrams, spawning, and scattering. We'll also see how these generated forms are ready for any fabrication process, such as 3D printing. We'll be looking at a suite of generative design tools which include the voronoi diagram, delaunay triangulation, point scatter, surface scatter, volume scatter, wrap, and parametric map modeling tools, and how they can be used together along with other formZ tools to generate complex organic forms and design structures in a very fun and intuitive way. Let's begin with an overview of how each of these tools work, then we'll apply them to some sample projects. These new creative modeling tools are found in the specialty suite of icons here. And so we'll take a brief look at how each of these tools work. Let's look at the point scatter. Just simply click on any object, solid or surface object, and you can see it distributes a series of points randomly across that 3D form. And there's plenty of parameters here to control the distribution of those points. So for example, we can take this little saddle shape that we have here, and when we click on it, we distribute our points, and we're in the result buffer mode. So we can go into tool options here and modify any of the parameters. We can set the maximum number of copies to as many as we need to be scattered onto the surface. We can also control the separation of the points. You can see some of these points are getting close to each other. So we turn the separate by option on, and then we can set some kind of range. And so you can see it automatically updates, and so no two points that are being scattered will come within a certain range of each other. There's also a setback option, so you can see these points are coming up right up to the edge. If there's any holes in here, they'll come right up to the edge of the holes too. And so the setback creates a sort of a buffer or a margin from those edges. So if I were to put a new value in there, it was at 0, now it's at a positive value, so you can see that there's no points coming within a certain distance of the edges of the object. So we have a little gap there. That would also include any holes that are in that object as well. There's also an offset range, which allows us to actually have the points distributed off the surface of the actual object. So there's a minimum and maximum range. Let's set a maximum value, and you can see that they're either right on the surface or they'll be a certain distance above the surface. And if we put a minimum value, I'll put a minus value there. So we got a minus minimum value and a positive maximum value. And then you can see that these points are following the contour of the shape, but they're also being randomly distributed within a minimum and maximum range that we have set there. So it's more of a three-dimensional distribution on the 3D object. And if you don't like the seating of how they are positioned along that object, you can click the rescatter button, and it reseeds the spawning to create a different type of scatter pattern onto that object. All right, so that's how the point scatter tool works. Next, we'll look at the surface scatter tool. Now that is very similar to the point scattering, except instead of scattering points, we're going to be scattering objects. And so I can take a box and scatter it on the wall, take a cylinder, scatter it onto the NURB surface over here, a little cone shape on this little egg NURBS surface that we have there. And you can also scatter multiple objects at the same time. So if I hold down the Shift key, I can select multiple objects. I let go of the Shift key, I click a blank area. Now I click on my object, and you can see that all those objects that I have pre-selected will be then scattered onto the object. And you can also see that it is maintain the actual grouping. So if you have groups of objects or components, or just based on the orientation of where they are when you select them, that's how it will be scattered onto the object. And there's also an option here in tool options that we can turn on the scatter individually, and you can see it treats them as separate objects then. So you can use the grouping or scatter them individually based on the settings that you have here. Once again, all sorts of parameters that we can use to control the scattering of those objects onto other objects. So let's take a look at a few other options and parameters we have in the tool options palette. So let's take a series of objects like these right here, and I'm going to select all of those holding down the Shift key, and I'm going to click my object. And you can see they are randomly scattered onto the surface of that shape. Now we do have control of the direction of the actual scattering. You can see that there is this direction option, so they're normally scattered onto the positive normal side of the surface. And if we change the direction to be in, then you can see they're actually going on the negative side of the surface. And so I'll give this a transparent color so we can see through the object, and you can see they're actually going to the inside or the opposite side of that surface. There's also other parameters that control the justification of how they're lined up on there. For example, we can go to the center, and you can see that they're halfway in and halfway out, so the center of each object is positioned right on that surface. And you can also control it by the origin, so if you really want to further articulate how these are positioned on the surface, you can actually choose the object axis. You can control where the object axis are for each of these objects, and then use the origin option to control how they're placed on there. Okay. All right. Let's try another variation here. What we'll do is take the cylinder, and we are going to scatter it, just the one cylinder on the object itself. Let's apply a few more and look down our list of options here. You can see we have some other things we can change here, like for example rotation and scale. This is sort of cool, so we can have random rotations and random scaling to our objects as they're being scattered onto the object. So I'm going to set, let's see, the scale from the Z anywhere from 1 to 5 times. So I put a factor of 5 in there, and we end up with an interesting shape that looks like that. The next tool we're going to look at is the volume scatter. So that allows us to actually scatter objects within the volume of the object. So that's sort of similar to the point scattering and the surface scattering, but now instead of scattering points on the surface or objects on the surface, we can actually scatter objects within the solid volume of the object. Let's try that. Click on our box here, click on our shape, and you can see that they fill in as many as they can based on the maximum value that you set here. So I already cranked that up a little bit. Let's try and fit 100 of them in there. And it'll try it. Now we do have the separate by option on, and so what that'll do is create a condition where they cannot separate or they cannot intersect with each other. It tries to maintain at least a 0 level of separation between those, so it'll try to fit up to 100 of them within that volume. Now if you turn the separate option off, you can see that we can actually create a condition where it can scatter them anywhere that they want within the volume, and you will get an intersection of those objects. Now let's apply a few other changes here. For example, let's try some scaling here. Now I'm going to start changing a bunch of parameters here. So instead of waiting for it to update every time I change one little parameter, I'm going to turn the auto update option off. And I'm going to scale those anywhere from 1 to 2 times larger, either in the X or Y direction. Tell you what, let's go anywhere from 0.2 up to 2 times the value. And once we get all of our parameters set, we click on the update button, and then we get a redistribution of those objects. So let's change the scale factor again. And you can see the fun with being able to work in this result buffer mode, adjust those parameters, and sort of have a lot of different conceptual design variations based on being able to manipulate those tool option parameters there. Okay, so that's pretty much how the volume scatter works. Next, we're going to look at the wrap tool. So let's see how that is working. What that allows you to do is to actually wrap a surface around any number of objects. And so what we can do is select a few objects here, and then I click a blank area, and there it goes. And you can see it creates a nice little faceted triangulated surface that wraps itself around those objects. And you can use as many objects as you want. So for example, I can grab all these boxes over here that were scattered within that volume and wrap a surface around those. It even works on 2D shapes. So if I were to select a few different 2D shapes here, you can sort of fill in the boundary or wraps the boundary around those 2D shapes, and even works on points. So it works on just about any type of object. So let's grab some points here and wrap those. And if we were to apply a transparent material to those, you can see it is conforming to whatever those objects are and wrapping sort of the minimal surface around those. And you could even wrap the wrap surfaces. I mean, you can actually mix and match the solids and the surfaces and the 2Ds and the points and all that stuff, and pretty much anything that you have selected, it'll wrap a surface around all that information. Okay. All right. Next, we're going to look at the voronoi and the delaunay diagrams. Let's see how those work. I think the best thing to do would be to sort of compare and contrast these two different diagram creating tools here. First one is the voronoi diagram, and that's an example of that, like you see here. And this is actually a set of regions or cells that are formed around a set of seed points. The program calculates a boundary around each point where any position along the edge of each cell is equidistant to the nearest 2 or more seed points. And the result is sort of an artistic diagram that emulates organic structures that are found in nature. And now this one over here is the delaunay diagram, and it's a set of triangulated regions or cells that are formed from a set of seed points and is derived from a series of circumscribed circles around each of the points, producing a diagram where the original points are at the vertex of each of the triangulated cells there. Okay, So let's see the different ways that we can use the voronoi tool to generate these voronoi diagrams. Well, there's a few different methods we can use. One of them is we can actually go in and generate it from just a series of points by itself. So I'll select a window of points, select the voronoi diagram, click a blank area, and you can see it actually filled in regions around each of those points. Some of the parameters over here would be the margin, and that is how far the outside boundary cells are from the outside boundary of the points themselves. So if I bring those points back, you can see that it has to fill in this outside boundary there. So if I set the margin all the way down to 0, then you can see the outside cells will conform to the outside boundary of the points themselves. And so you can control that with this margin option over here. Now the voronoi diagram can also be used on 2D shapes. So if I were to just draw a hexagon shape, and if I were to click on it, it uses where those points are, and it uses the same algorithm to generate the voronoi diagram. And every time I click on it, it then reseeds a new voronoi diagram based on the new points that are there. And so if I click again and click again, it keeps generating another one. So you can see here there's points along here. And so if I click again, each of those points now are the center of those regions. And so you can get some interesting shapes by starting off with some sort of 2D shape like we have here. Now you can also seed the voronoi diagram that's used on 2D surfaces. So that's done by either using the insert vector line tool. I can pretty much sketch some kind of design here. I can use the offset segment tool, maybe offset an edge over here. There we go. And so now when I use the voronoi diagram on that, you can see we have a different distribution of points, and you can see it's creating a different type of a diagram. So there's more of a symmetrical design to that based on the positioning of where those points are. So there's some interesting designs created from that. Now you can also create voronoi diagrams from both points and faces simultaneously. So for example, here I can grab a bunch of points and grab a face or the surface of a object. And you can see when I use the voronoi tool on that, it'll generate the voronoi diagram within the boundary of the set of points, but also conform it to the actual boundary points of the surface, and it'll actually project it onto the surface that the voronoi that you selected for the voronoi diagram. Okay. Now some other options here is we can do it as just a series of segments, as an actual surface with the information imprinted in there, or as a lattice network. And so you can see here I can actually give it a radius value, and then you can see that it creates sort of a tubular frame from that voronoi diagram. Okay, so we'll have some fun with that. We'll do some sample projects here in just a little bit, but that's basically how the functionality of that tool works. Okay, now for the delaunay diagram, that behaves the exact same way. So we can do all the same examples using this other tool. We can actually select points of surface or points and a surface. You select the delaunay diagram tool, click, and there we go. And now you can see that the triangulated surface is actually creating the regions or cells and using those points as the actual vertexes for that. And last, we're going to look at the parametric mapping. So let's take a look at that. With this, well, we can take any type of 2D shape and project it onto a 3D object. So let's use parametric map tool. I'll simply click on a 2D shape, click on my object, and you can see that that 2D shape is then projected onto the surface of that 3D form. And if you look at a top view, you can see there's our little diagram there, and that is imprinted into the object. If I were to undo that, we can take a voronoi diagram like we have here and project that onto the surface. And actually, we can actually generate voronoi diagrams directly on 3D surfaces, or you can actually do it as a 2D surface first and then parametrically map it on there. And we'll actually look at a couple examples of that in just a moment. And one last example would be using a hexagon pattern. So this is a pattern that we created ourselves. Just draw a series of hexagons imprinted onto a rectangle. And we could take this type of diagram, a custom diagram that we created ourselves, and have that mapped onto the object. And there we go. So now we have that imprinted hexagon pattern sort of tiled onto that 3D surface like we have there. Now that we have a quick overview of how each of these tools work, let's see how they can be used together along with other formZ tools to generate complex organic forms like the voronoi wall. And also see how the resulting generated forms can be easily 3D printed, just like any other object in formZ. So let's see how this was created. Go into formZ. We'll start off with a 2D flat plane. Just use the vector line tool to draw a shape. And then from that shape, we'll go to our point scatter tool. And when I click on that object, I scatter a series of points. So how many points do we want on there? How about around 25 points. Put a little bit of separation between them so that there's a little gap so they don't get too close to each other. And we'll also do a little setback so they don't get too close to the edges. Offset is at 0, so they're all lying right on the surface itself. And if I don't like the way it scatters them, I can just use the rescatter option and reseed that spawning for those points. Once I have that done, I can select all the points and the shape itself, and then I can go to the Voronoi diagram tool. Click on that. I click a blank area, and it will then generate a Voronoi pattern from the series of points within the boundary of that shape itself. Now at this point, it's a 2D flat surface, and what we can do is use the thicken tool to give it some thickness. So I use the thicken tool, click on it. There, now it's a solid object, and let's give that a little more thickness. So crank that up a little bit. There we go. All right. Now at this point, I want to punch some openings in here, so I'll use the offset outline tool, and I can generate an offset outline that's being imprinted or inserted into the object. And if I were to spend another 30 seconds or so, I'd be able to do all the rest of those offset outlines like we see there, which are being drawn onto the front faces only. And then using the reshape tool, I can then select that interface boundary and reshape it all the way through. Don't forget, you can hold the shift key down, select multiple faces, and reshape them all simultaneously. There we go. So if I were to reshape the rest of those, we end up with all the openings that we have just like that. Now this is one object, and you can see if this is the type of design that we want for the wall paneling, then fine, we're actually done. If we want to smooth it out a little bit, give it more of an organic look, we can use the subdivision modeling tool. I can just simply use the subdivision tool and click on it, and it converts that into a sub-D object, very smooth organic shape. And also don't forget, we have all the cage information, so we can go back and modify that original cage after it's created. All right. So at this point, we are now done. If we want to send this to the 3D printing process, we can do that. Just simply use the subdivision convert tool, and we can convert this to a quad mesh. So you can see right now it's a subdivision object. Click on it, and now it's converted it into a quad mesh, which is perfect for the 3D printing process. And that's exactly what we did here. I did a file export to an STL file, open that in 3D printer and print, and that's how we end up with our final 3D printed version like we see there. Now let's look at another example, such as the Voronoi tower, which starts with the same technique used in a previous example, then highlights other new ways that we can edit and manipulate these complex forms after they are generated. So let's see how this was done. I'm going to fast forward through the first few steps here. For example, we just drew a 2D shape, and then we used the point scatter tool to be able to scatter a series of points onto that surface. And then we selected everything, and using the Voronoi tool, we were able to generate a Voronoi diagram that was imprinted into the object. And then we used the thicken tool to give it some thickness. So we have a solid slab now. And then we use the offset outline tool to generate a series of offset outlines on each of the faces, just like we did in the previous example. And then we used the reshape tool to then reshape those interfaces out to get sort of a very similar type Voronoi cage object like we have here. Now here's where we begin to do something different. What we're going to do is take this object and rotate and copy it 3 times around to form the 4 sides of that tower. So using the rotate tool, we said copy it 3 times, and I'll take this thing and copy it right from the origin, 0, 0, 0. All right, and I'll type in 360 degrees, and there we go. Now the problem we have is in the corners here. We need to sort of line these corners up a little bit better than that, so I needed to adjust that slightly. And when I did my first example, what happened was that we had a very thin vertical column on the 4 corners, and when that 3D printed, it was sort of fragile, so we needed to beef those up a little bit. So I went back to the design, and I went to that original object like we had here, and using the reshape tool, I used the keep edges option. So I actually used the reshape tool to bring these side faces out a little bit to sort of beef up the corner vertical sections. And you can reshape multiple faces if you want, pull those all out, and then we end up with our final piece that looks like this. All right, so then we do a rotate multi-copy again with that new piece, and then everything lines up nice and neat. Plus we have a little more material there in the corners, which is going to help us out. Now if we go and select everything, And then we can use the Boolean union tool to then union all those pieces together. It now becomes one solid cage like we have here. And then to sort of smooth all that geometry out, we'll use our subdivision modeling tool. And if I click on it, it makes a nice smooth organic type shape. Of course, we got the controls to further articulate that sub-D cage if we want. Now I'm going to turn off the show edges here. And at this point, maybe this is what we want. We're done. But if you want to give this more of an organic type twisting, bending, bulging look to that, well, we can use the deformation tools on there to further alter or sculpt that 3D form. So let's try that. Now, here's a little tip for you. Right now, if you look in the wireframe mode, you can see that the subdivision object, the quad mesh, is rather dense, so we get a nice smooth object there. And what I'm going to do is use the subdivision modeling tool, and if I were to click on that, you can see I can actually reduce the number of iterations. So let's just make that 1. And now if you look at that in the wireframe mode, we have a lot less polygons there for that quad mesh. So this will make the deformation tools a lot more interactive and operate a lot quicker. So let's try that now. Let's do a bulging operation. Just simply click on the corner over here and grab hold of that thing and drag it, and you can see with that reduced quad mesh on that sub-D object, get live dynamic interactive deformations on there. Okay, let's try another one. Let's do a taper operation. So we'll do taper, click on it. There we go, drag the top in a little bit. And let's do a twist. Click on it and drag that around like so. All right, and once we get that pretty much the way we want, how about something like that? We need to increase that quad mesh back to its original value. So let's go back to the sub-D tool, click on our object, and let's change the iterations back up to number 3. So that'll actually increase the number of polygons in that quad mesh. Now I have a nice dense quad mesh there. Great for the rendering aspect of it, and also for the 3D printing. If I want to 3D print it, once again, just use the convert tool to convert to a plain quad mesh, and it's ready for 3D printing. And the higher resolution also gives us a better rendering object also. In this example, we'll create a voronoi saddle shape that is comprised of a network of solid tiles that make up the overall form, and this will highlight the ability to generate voronoi diagrams directly on the surface of complex 3D shapes. So let's see how this was done. We start off with a 3D form like we have here. And where did this 3D form come from? Well, if you go to the NURBS by Formula tool, you can see there's a whole series of different mathematical forms that can be generated through mathematical equations, and there's a library that's already set up for you. And I saw this one. This looks pretty cool. So I went ahead and created that, and we can modify a few of the parameters here to come up with some very interesting mathematically derived forms. Play with little sliders there, so on and so forth. So anyways, get the idea of where a shape like that could come from, or use the NURBS modeling tools. All right, now the first thing we're going to do is distribute a series of points along this 3D form. So we'll go to the point scatter tool, click on that object, scatter a series of points, and how many do we want on there? Let's put about 50 points on there. Let's put a little separation on there between the points, and also put a little setback so they don't get too close to the edges. Hit the rescatter a couple times until I get the distribution that I think looks good. So something like this perhaps, right? All right, now what I'm going to do is I'm going to select all the points and the surface itself, and I'm going to use the voronoi tool. So you see here, I can actually generate a voronoi diagram on 3-dimensional complex forms. So if I were to click on that, you can see we actually end up having the voronoi diagram imprinted as a surface into the object. It looks just like that. There we go. Nice little tile pattern on there. Now this is one object, it's one surface, and you can see these are just different faces of that object. So if I were to color those, you can see that those are just different parts of that one surface object that is there. So if I were to finish coloring all the rest of those, it gives us more of a abstract look at the different tiles that are there. Now, to make the thickness of the tiles themselves, we'll go to our thicken tool, and with that we'll set the thickness that we need. And if I were to click on each of those faces, you can see I can actually convert each of those faces into a solid object. And if I were to continue doing that for all of those, you You can see we end up with a whole bunch of solid tiles like we have here. And if I were to move this off to the side, well, you can see that those are separate pieces. And then the last step would be to apply some rounding to that, so I can set my rounding parameters. I can either try to round the whole object, or maybe just round faces or edges, and use the rounding or controlled rounding tools to round all the edges that are there. And if I were to spend a couple of minutes rounding all that stuff, we end up with our final tile pieces that look like this. All right, so if I were to turn off the show edges, we can see our different pieces that make up the overall form of that saddle shape by using a voronoi diagram to generate the 3D tiling pattern. The random point scattering, along with the organic cells of the voronoi diagram, created some very artistic characteristics on the surface. But what if we want to create a more symmetrical design pattern? Well, that's where the Parametric map tool comes in. Instead of generating a pattern with the voronoi tool, we'll create our own pattern and then project it onto a surface. For example, we'll create a 2D flat hexagon pattern and then project it onto a surface to develop the panel structures like we see here. So let's see how that was done. We start off with our 3D form like we have, and then we're going to create our own diagram that's going to be projected onto that surface. So we start off with just a 2D rectangle, and the rectangle can be any size. Now I drew it so it's sort of close an approximation to the size of the actual unfolded surface itself, but you can actually create that any size that you want. And then I drew a series of hexagons that are laying on top of that 2D rectangle. And these hexagons were drawn just using the polygon tool, give the size that we want, and then I used the move with the copy option to multi-copy that hexagon around, and you can see in a couple minutes you'd be able to generate some kind of array pattern of all these different polygon patterns. And once we have those, we can actually select all of those shapes that we have. Window pick all these down here, and then I'll go to the imprint tool, and I'm going to imprint all those shapes into my 2D rectangle. And now we have one object with all that hexagon pattern information inserted into the object. Now we want to take this and actually project it onto our surface. So let's bring our surface back. And here's the surface that we were looking at earlier. And then using the Parametric map tool, we're going to select our diagram right here. And we click on our object. And it picks it up and projects it right on there. And of course, we can control the number of tiles and things like that. But since I drew it as sort of a one-to-one shape, I actually tiled it 1 by 1 times, and it shows up just like that. And that is imprinted onto the surface. All right. So let's say we want to give that some kind of thickness. Let's say this is the actual framing structure for our hexagon paneling system. Now, the Parametric map tool doesn't have a lattice option like we saw in the voronoi tool, which is not a problem because we can just use the frame tool. And with that, we can set some kind of radius here, click on our object, and then of course each edge of that object then becomes a tubular frame of whatever radius we have set there. Now of course that's sort of big, so let's make that a little smaller. Once again, we're in that result buffer mode there, and we can actually generate some kind of lattice type structure from that pattern that was projected onto that surface. Now for the glass panels themselves, we can actually go back to the original surface that we had there, and then using the thicken tool, we can actually take those surfaces that we have and thicken those to whatever thickness we want for the glass. So if I were to click on those and maybe move one off to the side there, you can see now that each face has been thickened to create the actual glass itself, and we give that a transparent material. And there's our first basic concept for that hexagon pattern. Now if we look at the actual concept that we have here, actually we have smaller hexagons, and they're all connected with the framework in between each of the centers of each of the edges of the hexagons that are there. Well, that was another conceptual design from the same concept here, and we actually continued on with this design to create that by going into the original surface that we had. And here's where we had our hexagons imprinted into the 2D shape, and then we added more information to this. We can use the offset outline tool, and I went into here and offset a few more shapes, and if I were to take another 30 seconds or so, we would end up with another diagram that looks something like this. All right, and then we're going to parametrically map this new diagram onto our surface. So let's try that. Let's bring our surface back, And then we'll use the parametric map system to take this and project it onto the surface. And we end up with our final surface that looks like that. All right, so we got a lot more detail in here, and really all we need is the inner hexagon shapes. And so since all the stuff is imprinted, and what I'm going to do is derive some new surfaces just from those inside hexagons. And so using the derivative tools, I can use the derive face option. I can select multiple faces. I'm selecting just the inside ones. I click a blank area, and now you can see I can actually derive those inner surfaces. And then from that, if I were to select all of them, I'd end up with an entire network that looks like this. Now for the framing process, we can get the frame around here, but what about the frame that connects these pieces together? Well, I had to do a little extra manual work with that. I can just go in and use the line tool, and I drew a line by snapping to the midpoints where each of these hexagons meet. And like I said, take about another minute or so, and I could draw all the rest of those, and we end up with all the lines that connect those pieces together. And then I select all those objects. I use the frame tool on that. So let's select frame tool, give it the radius that we want, and we can frame all those pieces together. And what that will do is generate a 3-inch radius tubular frame from all of the selected objects. We have all the inner hexagon patterns, we have all of our lines, and you can pick as many objects as you want, and the frame will be generated with anything that you have selected. So there's our frame. And the glass was created the same way. We actually ended up taking all of those dry faces that we had, and we can use the thicken tool on each of those, and we end up with the final assembly that looks like that. Okay. All right. And one more variation of this too is, I don't have to show this, but I think if I have those dry faces, I can actually, instead of thickening them like a 1/4 inch for glass, I can actually thicken those a larger distance to create the panels. And you can see with using these new design tools, you're actually able to create a lot of different conceptual variations using those same tools in a different variety of ways in order to generate multiple concepts. Now let's explore even more ways that we can derive 3D form using parametric object mapping and use some new methods to derive the final structural components that make up the overall form, such as this archway. Believe it or not, this entire design was derived from a single 2D flat design pattern. So let's see how that was done. So let's start off with our overall form first. So with that, we'll generate, how about an arc? And we'll extrude that, flip over to the ZX plane. And from that arc, I'm going to extrude that a certain distance. And there's our overall arch shape right there. All right, I'm going to center that just because I just like things centered. So I'm going to move this thing right in the center there. And I want to give this some curvature, so I'll use the deformation tools on that. Let's do a bulging operation. Let's bulge it along the ZX direction here. There we go. And just sort of play with that thing and come up with some kind of a nice curvy form for our archway that looks like that. All right, now from the shape that we have here, we want to project some kind of design onto that form. And so we'll begin just like we did with the previous example. We're going to create a 2D rectangle. And the rectangle, you could match the overall size of the unfolded surface if you want, or in this case, I just drew an approximate shape of the actual size there. And I created a series of circles. And the circles, these are separate circles. So you can see if I were to move these off to the side, I created one circle, and then I did a move multi-copy and just copied a whole bunch on there. And then I'll select all those circles, and then using the imprint tool, I select my 2D rectangle, and that actually imprints all those 2D circles into that shape. All right, so now they're inserted. This is one object now. And I can continue on adding more detail. For example, the offset outline tool, like we did in the previous examples. I can do a little offset outline in there, offset outline for this face. Use the insert line tool, whatever you want. Draw with the insert option on. So for example, here we can use the vector line drawing tool, use inserting. I mean, whatever you want to do to be able to create that type of diagram pattern. And this is the final one that I ended up with here. Now we want to pick this up and map it onto that surface. So let's bring our surface back and go to our PMap tool. And we're going to select our 2D diagram and click on our 3D object. And of course, because of the shape that I've drawn this, I am tiling it one by one, but you could actually do a smaller section, and then you could tile it multiple times across that surface. And another thing that helps too is you can actually take that 2D shape and you can actually rotate it. So if you want to control what direction it's going to go on there, you can actually take your 2D diagram and rotate it 90 degrees, and it'll be positioned the opposite way on that surface. So you can see it took 5-10 seconds to be able to generate and insert all that information into our form like we have right there. Okay, so now at this point, what we're going to do is we're going to begin to actually build the actual components, or derive all the components that make up that archway from this 2D information that's mapped onto that object. So how's that done? Well, there's many things we can do. For example, one is I can actually start to delete some of the faces that are there, because this is one object now with all that information inserted in there. So I can use the delete tool to delete some of the faces here, which will give me the openings of that archway. I can also use the thicken tool to thicken some of the faces there to build up all of the components that make up that object. So let's zoom in here and let's click on that face. We're going to thicken that one. And you notice I'm holding down the Command key on Mac or the Control key on Windows, and that allows me to select on just faces. And when I create a thickened object, it's going to drive a new object from that. Let's assign a different thicken value from that. Let's give it a thicker value. And I'm going to select these faces like that. Select the circles, the circular faces. I'm just deriving objects from the existing geometry that's already there. All right. So now if I were to move this object off to the side, you can see what I'm doing. I'm actually building off of that. So all these components that are being created are deriving themselves from that parametrically mapped diagram on that surface. So if we were to continue on deriving those objects, we end up with our final archway that looks like this. In our last example, we'll use the Surface Scatter tool to help us derive a random array of 3D relief objects on the facade of a building. We'll use the Scatter tool's random location, rotation, and scale parameters, along with interactively tweaking the result buffer parameters to explore an endless array of scatter patterns. We'll begin with our facade wall that we have here by creating some basic shapes. And let's scatter some of these on the facade of the wall here. So let's try this rectangular shape that we have here. So we'll go to our Surface Scatter tool, select our object, and I don't want to scatter it on the entire object. I want it to be just on the front face. So I'm going to hold down the Command key on Mac or the Control key on Windows. So I'm scattering it just on the one face of that object. And you can see it'll scatter it onto that surface. And then we do have control of the direction and justification. We'll center it through the thickness of that wall, and it'll position them on the wall just like that. Now here's where we can start to explore different types of design iterations here by playing with the different parameters here in the tool options and the result buffer mode. Let's try to add more here. Let's do maximum copies 100. So I'll try and squeeze more in there. Well, there's not a whole lot of room there to fit more in there, so it's probably not going to add a few more. So what we can do is start to scale these things a little bit. Let's give them a different size. Now as I start to change a lot of parameters, what I can do is turn off the auto update option, change the parameters to whatever I want. So let's go anywhere from 0.2 to maybe 1. Let's try that. Now I don't want to scale it in the Z direction. I'll leave that alone, so it'll just scale the X and Y only, so they'll all stay the same height. When we got our parameters set the way we want, you click the update button and it'll calculate or reseed the spawning of those randomly scattered objects on that wall. Now we also have a couple cases here where the scattered objects are getting pretty close to the edges here, so we know how to resolve that, right? We can actually put the setback to a certain distance so that you don't come close to the edge. And we can also turn our separate option off. Notice that none of these are intersecting anywhere. So if I turn the separate option off, put a little setback so they don't get too close to the edges, I can click the update button. Now we can get a lot of intersection with those shapes if we want. And here you can just keep playing with these different parameters and come up with all sorts of different variations of that. And if you don't like the seeding, just simply rescatter again and try some different variations like that. Now these are 3D objects that are created that are being scattered on there, and you can see we can do things such as grab hold of some of those. We can do a Boolean union to union those pieces together. So now that forms one single object. We can do a Boolean difference. Maybe we want to subtract those scattered objects, which are all union together from the wall itself. So we can actually take the wall, subtract that out. Now we have a recessed area. And so whether it's the facade of a wall or product design or whatever you're using this for, you can integrate it well with all the other existing tools within formZ. And this concludes the generative design in formZ presentation, and we look forward to seeing how these generative modeling features will be used to enhance your modeling and design creativity. Thanks for watching.